So this is for integrated or liberal arts math. It is I don't remember which one it is. Hold on. Part A, Unit 3. I want to make sure I'm saying it right. Solving linear systems of equations unit. Unit activity, systems of equations. Okay. So I'm going to be reviewing how to complete this, and this should help you get it done. Okay, so the first task 1 is self-publishing. You've written your first novel, and like many first-time authors, you can't find a publisher, so you want to self-publish your book. You need to work out the cost of printing the book. If the cost of printing the novel includes a base cost of $15.50 plus $4 per book, write a function that represents the cost of printing X copies of the book. Well, the base cost is $15.50, so that's going to be plus $15.50, whatever your base cost is. Like no matter what, it's going to cost you that much flat fee, plus $4 per book. So per means you're going to multiply. And $4 per book, 4 times B. Oh, X copies. I used B for book, but they're saying it's X, so I'm going to make that an X instead of a B. $4 per book for X plus the flat fee of $15.50. Okay, part B. If you want to cover the printing cost by printing and selling only 50 copies of the book, at what price must you sell the book? So if you're only selling 50 books, you're going to plug in 50 into your thing for books plus 15.50, and 4 times 50 is 200 plus 15.50, and that's going to equal 17.50. So like that's the total cost, 17.50, of what it would cost to produce the books. How much would you need to sell the books for? So if you're only making 50 books, then you would divide the total cost of what it made of, can't talk, total cost of what it is to produce the books, the 17.50, and then divide that by the 50 books total. So you would have to sell the books for $35. That's what you get when you divide it. And then part C, based on the book price per copy you calculated in the previous task, write a function to represent your income if you sell X copies. So if it's $35 per book for what you're going to sell, then it would be 35X. Okay. I'm going to have to clear this off and scroll down. Okay, so after spending $200 on market research, you discover you can sell many more copies of your book if you price it at $20. So instead of spending or pricing it at $35 a book, you're going to price it at $20 a book. Write a new function for both your expenses and your income from selling X copies. So if you remember up here, the cost of printing the book is 4x plus 1550. So that's not going to change. But you spent 200 on market research, so you'll have to calculate that in as well. So 4x plus 1550 was the original cost of producing the books. Plus the 200 on market research, right? Then, so the new equation for the cost of producing the book was 4x plus 1750. And now you're going to price it at $20. So let's plug in 20, 4 times 20 plus 1750 to figure out like the your break-even point. So that would be 80 plus 1750 or 1830 is how much you would have to make to break even. So 1830 divided by 20 is how much? It'll tell us how many books we have to sell to break even. Okay, 1830. So you would have to sell 92 books to break even. And 20x would be your function for like how much money you would make by selling the books after your break-even point. So this is your expenses right here. And I would say that you would have to subtract the 1830. This is your income. Okay. Now, use the graphing tool to graph the two functions you wrote in Part D. Examine the graph and estimate the minimum number of copies of your book and print and sell to avoid losing money. Capture a screenshot and include it with your answer. So I don't know if I'll be able to access this or not. I'm going to write down my formulas on a sheet of paper for x and 20x. Oh, this opened up in another window. I don't think it's going to let me do it because I'm a teacher or content coach. So I'm trying to open it in another window to see if I can do this or not. Nope. Okay, so because I am a content coach, it is not letting me access the Edmentum graphing tool. I'm going to use a different tool called Desmos. Which should be similar. And let me share I'm not sure if it's sharing the right thing or not. Okay, so now you should see the Desmos calculator or graphing thing, and it's just desmos.com. If you don't have access to the graphing thing in Edmentum, you can also use this. So I'm going to type in the two formulas that I wrote down, starting with y equals. Okay, so 4x plus 1750. And I'll have to zoom out of this. Okay. And then the other one is y equals 20x minus 1830. Okay, so see, one is a red line and one is a blue line, and I can look to see where they cross right here. Oh, I'm going to zoom in a little further to be as exact as I can. And this will be like the solution for both of them. So it looks like they cross. Right here. I'm not sure if that's 0.75 is right or not. That's why I keep zooming in. Okay, so the X value is 223, or basically 224 books. I'm going to go back to my other screen. Okay, so when it says examine the graph, estimate the minimum number of copies of your book, that's what we just did. And it was 224. You would have to print and sell 224 in order to not lose money. So you would have to include a screenshot of your graph that you made and then have the written answer, 224 books. Okay. So that was the exact number of copies, 224 for F. Okay, so school fundraising, this is like a separate problem. Your school is planning a fundraiser dinner. The expenses for this event must not exceed or go over $2,475. The team organizing the event has calculated the cost per adult will be $18 and per child will be $9. The venue can hold no more than 150 guests. So this is a classic systems equation, and we have to write the system for part A. So we know that I'm going to make A adult and C child. So if it's $18 per adult, that's 18A, plus $9 per child, 9C, and that can be no more than, so it has to be less than or equal to 2,475. And then for the second part, it can hold no more than 150 guests. So adults plus children has to be less than or equal to 150. So those are our two inequalities. And using the graph, determine the maximum number of adults who can attend the dinner and fill the venue. So if I had like a point, let's say adults is X and children is Y, okay? So I'm gonna jump back over to my graphing calculator again. Let me share the other screen. Let me make sure I get the. Okay, so now you should be able to see the Desmos calculator, and my formulas erased, but I think I can remember them. So there was, let's say adult is X and child is Y, so 18X plus 9Y, and then I forgot how to put a less than or equal to sign in here. So I'm just going to put less than 2475. I'm not sure why. Oh, there it is. I was zoomed like way out. Okay. Should have recentered my graph before I started. Okay, and then the other part was adults plus children. So adults is X, children is Y, and there has to be less than 150 people for the venue. Okay, so where these two overlap, where the green and the purple overlap, like, I don't know if you can see the arrow on the screen, but it includes 0, 0, and it's less than 150 on the y-axis and less than, I don't know, like 140 on the x-axis. So your question was using the graph to determine the maximum number of adults who could attend the dinner and fill the venue. So adults was X, the X value. So if I, like this point right here would be like 120 to 24, 26, 28. So I would say 122 for going by this point right here. But if we're going by the point on the x-axis, it would be 137. You can't have like half of it an adult. The 0.5 counts for like half of a person. So you can't have half of an adult. So 137 would be like the maximum number. If there were no kids, you could have 137 adults. Okay, so that would be the answer to part B. And then let's see, if the event were held in a venue that can accommodate 200 guests, what's the maximum number of adults? So instead of 150, I'm going to change this to 200 and look to see where they still cross. And it looks like um, it's still at 137. Oh, it could be 200 then. If we're dealing with only adults, then 200. If we're dealing with, I think it's still at 137. What do you think? Okay, part D. If you want to find a venue with a capacity that guarantees you cannot go over budget, what's the maximum number of people the venue will hold? So I am thinking that because those two numbers are the same, that it would be 137. Okay, part E, the school aims to raise a minimum of 5,250 after paying for all of the expenses. If the school collects $50 per guest and chooses a venue that can seat no more than 150 guests, what is the minimum number of children that must attend the event? So I'm going to change my purple graph to 150 again because it says they can't go over 150 guests. And they're going to raise 5,250. So that's not going to be on the graph. Because these graphs are just showing like the expenses and the capacity. So we would have to add another graph to this. If the school collects $50 per guest and they're going to raise a minimum of 5,250, so, and they want to know what's the minimum number of children. It doesn't determine between child and adult for $50 per guest. I would say you could do 50x plus 50y is less than or equal to 5,250 because it costs the same no matter what, $50 per guest. So 50x plus 50y is less than or equal to 5,250. It almost looks parallel to the other line, doesn't it? So what's the minimum number of children? I would say 0. if we're looking at, if there was 105 adults, there could be 0 kids. So let me do 5250 divided by 105, and that's 50 adults. If there were 50 adults, you could have 0 kids and you would still meet your requirement. Okay. All right. So let me switch screens again and go back to the systems of equations. I hope I am on the right screen. Yes. Okay. So now we're on task 3, ancestry of a male honeybee. So honeybee reproduction is an interesting phenomenon. When a queen bee lays an egg, the egg does not need to be fertilized by a male honeybee to hatch. The egg will develop into a male or a female depending on whether the egg is fertilized by a male honeybee. If the outcome is determined by the following rules. If an egg is not fertilized, it hatches a drone or a male. If it is fertilized, it hatches a worker or a female. So the drones are male and the workers are female. So based on the information, how many parents will a drone have? Well, if it's not fertilized, it's a drone. So that would only have 1 parent. How many grandparents? Okay, so I gotta scroll up a little bit. Okay, so a drone will only have 1 parent because it's not fertilized. How many grandparents will a drone have? Well, so like, let me make a little bee family tree. Here's a drone, and it only has 1 parent, the queen. And the queen is a female, so the female has 2 parents, the queen and a male. So how many grandparents will a drone have? So that would be 2. And then how many great-grandparents, great-great-grandparents, and great-great-great-grandparents will a drone have? So if I were to continue my line of my family tree line, let me erase this one right here for the drone. So this is parent. Oh, I gotta put my pen back on. This is parent, this is grandparent. So the next line is going to be great grandparent and then great, great, great. Okay, so great grandparent is this, great, great, great grandparent is this. And then great, great, great grandparent is this. So I'm just making sure I get enough lines up here. Okay, so the male egg is a drone and does not have parents, right? So that only has, well, it only has the queen as a parent. The queen has the queen and a male. And then, so the queen has the queen and a male, queen and male. The male only has the queen. I'm sorry, you can't see this very well. And then for the last line, we have a queen here. So that would be queen, male. The male only has the queen. This queen has a queen and a male. This queen has a queen and a male. And this male only has a queen. So for the great grandparent right here, that's 3. Okay. And for the great grandparent, let me make this, say this line right here in orange is 1, 2, 3, 4, 5. And then for the last line, I'll make this in pink. So that's 1, 2, 3, 4, 5, 6, 7, 8. I counted 8 different grandparents. So write the numbers together and determine what kind of sequence they form. So our sequence is 1 for the parent, 2 for the grandparent, 3 for the great grandparent, 5 for the great grandparent, and 8 for the great grandparent. So is this, are we adding or are we multiplying? To get from 1 to 2, it's +1, 2 to 3 is +2, then it's +2, then it's +3. So just simply adding may not be a consistent enough of a pattern. So I'm guessing it's going to be a geometric sequence. Because when you're multiplying by a fraction or by a different number or an exponent, it would be geometric. If you're just adding like +1, +1, +1 every time, then it would be an arithmetic or arithmetic. I don't know if I'm pronouncing that right. All right, so let's clear the screen. Okay, so write the sequence using a recursive function. Okay, I should have. Okay, so my sequence was 1, 2, 3, 5, 8. And the first term is 1. The 5th term is 8. So what would the pattern be? I'm thinking. I haven't quite figured it out, but you're trying to write a sequence using a recursive function. I'm going to reference the lesson really fast to see if I can find it. I'm not seeing any examples of writing a sequence in the lesson. I'm going to pause this really fast and then come back to you. Okay, I don't know why I didn't see it before. So this is a Fibonacci, and I should have looked at the question below it to take some reference clues, but Fibonacci sequence is found all over nature, and the pattern to this is you add the numbers before it. So like 1 + 2 is 3, 2 + 3 is 5, 3 + 5 is 8. So the next term would be 13. 5 + 8 is 13. So it is a Fibonacci sequence, and the rule, like your terms are n, well, like the number, like this is your first term, this is your second, this is your third, this is your fourth, this is your fifth, and these are all n, like what number and line they are if you line them up. So your number, like if it's like x1, it's going to be 1, x2 is going to be 2, x5 is going to be 8, okay? So your rule is, oops, your first term. So plus your second term. Okay, so use the internet to research and list at least 3 other real world situations you can model with the Fibonacci sequence. You can do this on your own. But if you Google Fibonacci sequence, you're going to see all sorts of different patterns in nature. So find 3 real world situations where Fibonacci works, okay, and answer that. And let's see, for G, it says, in your research, what famous number or ratio related to Fibonacci sequence did you come across? And you can also answer that on your own. And I think that is the last thing. So here's the rubric for how I'm going to grade it. If you followed along with me and then answered the final few questions on your own, you should get 100. Hope this was helpful.